wait. Why aren't you global? Did you try the globe? And just tell me, because I assume that you are a grown ass person, so you are not just a kid. So
I'm 15 from Mumbai,
you
Delhi,
heard
India.
no, wait. You heard about the globe. Why aren't you a glober first?
Because the earth is flat. Like I'm standing on a flat
You're
surface.
capping,
there you
bro.
go.
Welcome to flat Earth. So why
There you
are
go.
you asking
Well,
about the
answer
flat
question.
Earth if you know that it is flat?
There you go.
What?
Because I don't know if the whole earth
You
is
just
flat or
you
not.
just cornered
Like
yourself.
I just know I'm standing on a flat
Well,
earth.
just your area is flat,
Thank
right?
you. We
Okay.
too.
Yeah, just my area is flat. That's all I know. I don't know if the whole earth is flat or not.
Oh,
Just know
just your area is flat,
Just
and the
it's
other area,
I'll concede that. Yeah, I don't mind conceding that.
the other area.
The water somewhere else might
So
be
you
different.
never moved from your house ever. So the area around your house is flat. 3.6 kilometers or miles in front of you, so the limit of your vision, or 10 miles in front of you, that radius, you never moved from that. So that radius for you is flat, but because you never moved even an inch, the other radius next to you, you don't know if it is flat too.
Killer combo.
Listen, is what I'm asking. This is not a valid question. Like, where does it end? Like, I get your point.
You don't even care what your worldview ends.
we don't know.
Let us welcome you to the flat earth first, and then we can discover if there is an end or not. Because we
Exactly.
don't know too. We are just like you. Flat
Does it
earthers,
matter?
the surface is
doesn't
not
matter.
curving.
We just stick to the facts, and you want to go beyond that and act like we have some sort of position that we don't hold.
Don't know, don't care. How's that?
We don't care, and they don't care either. That's the one thing I want to highlight the most.
That's right. It's a double standard. Exactly.
It's a weird double standard because they have a big worldview where their edge is a mystery. They don't know where it is, but they're like, I need to know where yours is. No, you don't.
So
No,
some
it's not
applause
the
to
same. Like, so
some applause.
do you guys,
Wait,
do you guys,
Castle. I
can I
just want.
ask something? Can I just ask something, please?
I
What was that?
So
I just.
can I just please ask something? Do you guys think there's like so in your worldview, yeah, let's say the ocean. Do you think the ocean just keeps on going?
No.
No,
No, I mean, that's a more fair view. Like I could buy into that. If I think like I don't know, like I don't know what you think. Yeah, you guys even know don't
That's
know.
not
what you think.
inherent, though.
But the ocean doesn't keep
How would-
going. We always end up somewhere.
Yeah, in the where? Yeah, that's the
Because
question.
we're always fucking going somewhere or following things that are going circular paths or circular coordinates like east and west.
Wait, circular.
Water requires a
Those aren't
container
circle.
also. Liquids require a container. So there's going to be a shore for any body of water.
Yeah, just like you know that there is some sort of barrier to hold in the gas pressure. You also know that there's some sort of barrier that holds the ocean. So there must be a bottom of the ocean.
There's a barrier?
You can't
Yes.
reach the bottom of the ocean, but you know that there is one. You're not going to be able to say, "Oh, actually, the bottom of the ocean is doesn't exist," and it's
Another outer
going
space.
on
Oh my God.
forever
You
and
just mentioned
ever and ever.
just a container.
Yeah.
There's a container for the ocean. You know
Containers
that.
have edges.
There's also a container for gas pressure. Same difference.
Mhm.
There's a barrier.
Where is this container?
The
Where's that?
earth under the water would be your container that you're asking for the ocean.
Where's the one for the air? Where's the one for the air?
It's
In the
somewhere.
sky.
It's
And
somewhere.
here we go.
It has
Another
to be
double
because
standard.
there's gas pressure. That's the confounding variable there. You've got gas pressure.
What do you mean a container for gas? I don't
You
know.
need a
Talking to someone
container
else
for
at the
gas
moment, Rob.
pressure.
Take a
That's
seat.
what.
Mute up.
Yeah. I mean, you can have a globe, for example, with air on it, and then it's just
No.
That's not a container, no.
No. You can have a globe like a ball with air. But hold on, with air in it. So the ball contains the gas. And because the ball's there, it will keep the gas there. If you put the gas on the outside of the ball, the gas will disperse
Why do you think so?
because that's entropy.
That's
It's a law
the
of
second law of
nature.
thermodynamics. Duh.
All right.
Well,
There's nothing to do
no,
with
if you have gravity, that doesn't make any sense.
No.
You don't have that.
God, here we go. You misunderstand what is being said to you. So it's a law of
If
nature.
you have a box,
My friend.
Okay.
This is a law of nature. That means it happens always. If it doesn't happen this way, that's a violation. If you're claiming it doesn't happen this way, well, that's a violation.
I
You're
don't
going to
think
need.
entropy has anything to do with it.
Sorry, it has everything to. Sorry, it has everything to do with it. Gas
I don't think so.
expansion. Sorry, excuse me. Gas expansion into a space is entropy.
Yeah.
Mhm.
But if the gravity
That's what
is
that's-
overcoming the expansion of the gas,
Again,
it's like having a box.
again,
Hello?
a box, a container.
Okay. Yeah, this is like having a box just with an open top. You're still getting pressure on the bottom and the sides.
That's not what a
I know
globe
it has
is.
an open top.
Excuse me. What happens if I've got a container of gas and outside the container there's a vacuum, and then I open the box? What happens to the gas inside the box?
On Earth?
Well, it's
No,
going to go out. Yeah, there's a pressure differential, so it's going to escape into the vacuum.
You don't
Okay.
have another
So
example of
that is thanks. So that is the simplest description of entropy. Gas fills space. You understand the reason why the gas stayed in that volume, height, width, length, was because of the container around that volume, the height, width, length. You
Not
understand
necessarily.
the consequent. Hold on. You understand the consequent of containing that gas is the gas is under pressure. These are simple laws of nature that we work with all of the time. Now the question is, the question is, being as this is a law of nature that works all of the time, the reverse doesn't happen. How do you have gas pressure? How do you keep a gas in a defined volume without a container?
Well, because the gas can be under acceleration and buoyancy would keep it in the container.
In the container, no, there's no container.
But
What happens to the gas? What happens to the gas? We did this earlier when we opened the box. What happened to the high pressure inside the box when it was open to a vacuum?
If it's under an acceleration, it could actually stay in the box.
Under an acceleration. We don't observe this under an acceleration. Sorry.
Yeah,
we don't
that's what
observe
gravity
this.
is.
No. Sorry. Again. We don't observe this acceleration. Gas
don't observe gravity?
expands. Excuse me. No. Gas expands, the second law of thermodynamics. When you say it doesn't, that's a violation of that law. The fact that you say that it doesn't means that we would see it. We don't see it. That's why the law exists. You're making a claim outside the law.
We see if you have gas, it has pressure. That's why we have air pressure at let's say sea level.
Of pressure. What's the definition of pressure? It has pressure, you said. What's the definition of pressure?
I don't have it on me. Maybe we can have an operating one.
That's okay. I'll tell you. I would have hoped you would have understood what it was, being is what we're talking about. It's the force
but I don't want to, just make one up.
It's okay. It's the force that the gas exerts upon the walls of its container. Remember the container of gas that we had there, and the consequent of containment was it was under pressure. Yeah, that's because it was
contained. I don't think it has to be in a container.
Yeah, it does. It's PV equals NIT. P stands for pressure, and it's solved by force over area. The area you get from the volume, described in feet or meters, and there's a physical boundary for the F, the force, the gas to press against.
I'm looking at the definition. It's the force exerted on or against an object by something in contact with it. Acceleration would cause a force. Force exerted, yeah.
No.
Yeah,
do you remember the bit where it said something? No, do you remember the bit where it said something solid has to press against something? You know why it's called pressure?
It doesn't have to be solid. It can be a liquid or a gas.
Okay, but I'll go with it has to be a solid, and I'll go with it has to be a liquid.
It's not true,
but you just said it was. You said you go
with solid. It can be a solid, liquid, or a gas.
Yeah, the gas is going to press against itself, but it's not going to contain itself. Gas expansion, right?
Well, I mean, if you're on the surface of a globe, then it's going to contain itself because it's going to be pressing against itself.
No. Remember that the way that you contain gas with a globe is by putting the gas inside the globe. When the gas
you could put it on the surface as long as there's the acceleration through gravity.
Okay, but there isn't, because the second, it's like I'm repeating myself, but it's not quite getting in. It doesn't, because
I don't think you understand
the law of thermodynamics is a law of nature.
Okay, I know what entropy is. I don't think entropy has anything to do with it here. Like I said,
it's gas expansion.
I understand there's gas expansion, but there's acceleration which keeps it contained on the surface.
You keep talking about this acceleration, right? Which direction?
Gravity.
Sorry, which direction is gravity? What vector does it have?
Towards the center of mass.
Okay, so downwards relative to the observer.
Depends the orientation of the observer.
Depends.
The fuck?
Yes. It depends on the orientation of the observer. The center of mass can be relative to the observer.
So downwards, towards the center of mass.
Yeah, if you're standing up straight on the surface, yes, it would be downwards.
Yeah, we're going to stand up straight, not going to lie on a sofa. But you can lie on your sofa, but you know what fucking down is.
Yeah.
Good, it's fine, we know what down is. Which direction? Okay, which direction does gas go? You drop a rock, it goes down. Which direction does gas go?
It'd go down into the sides. Depends actually on the density of the gas. So actually, it can go up. I mean, you can see helium, for example.
Mm-hmm. It's going to depend on the temperature. It's going to depend on the density. But when it's produced on and within the surface of the Earth, it's going to go up.
Mm-hmm. No, it would go down into the sides.
In actual fact, let's get this right. Mm-hmm. It has infinite degrees of freedom. Unlike a rock, doesn't have infinite degrees of freedom. It's just got fucking one. It'll go down when you drop it. Gas, though, it goes omnidirectional, in all directions.
Not if there's an acceleration.
You keep saying, if there was an acceleration. There isn't an acceleration because gas expands to fill volumes.
But acceleration can overcome that.
Can it? Show it.
Yeah, sure. If you have a dense gas and you put it in a box, it's going to sit in the box even though the top of the box is off. It'll just sit in there.
Okay.
No,
So what are you going to be able to?
Sorry, it won't
Just like
sit
cold
there.
air will sit at the bottom of a
it
box.
won't. It will disperse over time.
No, it will not. No,
It won't
Yes, it
just
will.
sit
it'll sit in the
there.
box. It'll sit in the box.
It will. The temperatures that are different will equalize, right?
Doesn't matter. The gas can be
Thermodynamics.
denser than air.
I mean, it fucking doesn't matter.
It doesn't.
Of course
Because
it
if you have a
matters. It's the
gas
very
that's
thing that we're
denser than
talking about.
air, it's going to sit in the box.
It's going to sit in the box.
Yeah, it won't go up
What
and out.
happens if I remove? What happens if I remove the box?
And then it's going to spread out evenly along the surface of the Earth.
Boom.
Yeah, it's going to disperse into the surrounding gas.
Yes, down into the sides, not up.
Yeah. It's going to go up. It goes in all
No,
directions.
it won't go up because
Yeah.
it's denser.
Yeah, it will disperse over time. Eventually,
Denial.
5 hours later.
It won't go up,
It's just
though.
fucking
You could just do this yourself.
Sorry,
if you
what
want.
time frame? Sorry, what time frame are you talking about? It won't go up.
Like
now
a
understand the whole
minute, an
life
hour, a
cycle.
day.
A week, a year, something else will happen
Yeah.
to it. Yeah.
Unless something else acts on it, it's not going to leave the box.
Yeah. Notice the only thing that we've been allowed to do here is vary and manipulate, I don't know, temperature and density. Right?
Yeah, the
That's going to
density of
change
the
the
gas.
pressure.
Yeah.
Pressure is defined by force over area. That's
No, we're not
not
talking
you.
about pressure.
Sorry, that's not you proving gravity, dude.
But we're not
It's not
talking
you
about pressure.
proving-
We're talking about a denser gas sitting in a box without a lid.
We are talking about pressure. The question is, how do you have gas pressure without a container? The container, as we know,
Because of the
E equals
acceleration.
nRT, is the force of the gas exerted upon the walls of the container. Pressure. Need something
I
to
explained
press
this to
again.
you already.
Okay, so give me the experiment then.
Yeah, I told you. You can have a box with
No,
a open top.
you don't understand. So you've got the phenomena of gas pressure. You say it's caused by gravity. I need that experiment, please.
Yeah, the higher altitude you go, the lower gas pressure it's going to be.
No, that's just one pressure that you're trying to cause without a container. Just
But
because
the
you can go
container is the
somewhere and
surface of the
measure. Sorry, just because you can go somewhere and measure a different pressure doesn't mean that the different pressure is the cause of gas pressure.
Anywhere you go on the Earth, you're going to have a different pressure. Or you're going to have a different gas pressure.
Weird, you don't understand.
Higher you go up.
Trying to speak really slowly to you, so you do understand, and then the next things come out of your mouth are just baffling to me.
I'm explaining it to you. I just don't think it's sticking.
You're not explaining it because X and delta X. What's X? That's gas pressure. Delta
You
X
said
is
X and then change in X. So what's X? What are you talking about?
exactly. So you need the X first before you can have the delta X.
X can be anything before you
Gas
can change in
pressure.
X.
It's gas pressure.
Okay, so gas pressure.
Yeah, X is pressure. You go somewhere else and measure a variation, delta X. We're not asking you about to go somewhere and measure a delta X. We're asking you what causes X. We need you to cause X with gravity.
Yeah. So the amount of air, the gravity, the acceleration is pushing that air against a surface, the container, which is the surface of the Earth. And the further away you get from that, the lower the pressure is going to be because it's no longer being exerted against the surface.
Okay, that's a great statement, but I'm still waiting for the hypothesis and experiment.
Yeah, so like I said, you could have a box, and you could have a dense air in it, or dense, some kind of gas in it, and you could see that the gas will not expand out and out of the box, especially if it's denser than air.
It's in a container. You're causing pressure with the container. I need you to not cause pressure. Sorry, I need you to cause pressure with not a container.
No. The whole point is that. Hold on.
And tell me what's happening. Why are you not getting this?
You're missing the point. There's no top.
I'm having to raise my voice because I don't want to mute you. I'm asking you to cause gas pressure without a container, not put gas inside the container and tell me what's happening.
No, the point is that there's no top.
His point is talking about,
there's no top.
I understand. Just let me clarify it. He's talking about, for example, putting hexafluoride inside a bucket and leaving the air pressure, normal air pressure, exerting the pressure on its surface, so the hexafluoride will not leave the bucket.
Correct.
So that's what he is saying. No.
Hexafluoride will still leave the top.
It will not leave the top.
It will over time.
And also,
it will not leave the top.
Yes, it will over time.
It will not leave the top.
It will, brother. It will if it doesn't leave the surface. So the major surface that we are living on will just be full of hexafluoride, both hexafluoride, tungsten hexafluoride, sulfur hexafluoride, radon, xenon, krypton.
This is how mustard gas works in war. It settles into trenches.
Brother, you will have the layer that we are breathing. We will have the layer that we are breathing now. Only with
this is why caves are so dangerous. This is why caves are so dangerous. Correct.
Over time.
You are entirely correct. Yes, this is exactly why low areas in caves are dangerous because these gases exist.
When the guys were like Jedi, were talking to you about showing or demonstrating gas being contained by gravity, not gas in being contained by a container and having a layer of air pressure inside what's called the atmosphere. So that will be a begging of the question fallacy if you do that. So when you want to talk about hexafluoride being attracted by gravity, so we'll have to put the container of hexafluoride inside the vacuum chamber. You pull the entirety of the gas that is around that container full of hexafluoride. Then you open the container, just the lid. You take out the lid and you leave the container there like a bucket or a cup. It will be like a cup, but with the open lid, and pray God that the hexafluoride will just remain in that container, not fill the vacuum, just because gravity will help it stay there. No, it won't.
Believe it or not, if you give it enough of an acceleration, it'll stay in the bucket. You just need higher acceleration.
Yeah, there is enough of acceleration in all sides of that container. So when you put barometers or gauges that can measure the pressure inside that container full of hexafluoride, you will measure the pressure in the entirety of that container, in the top, in the bottom, in the sides. So there is already an acceleration for because of that gas, and that pressure is because that pressure is because in your model, the collision of gas molecules against each other and against the walls of the container. And also, I want to add something. We won't be able to use gas containing gas because in measuring gas pressure, collision between gas molecules between each other inside the container is excluded. Only the collision between gas molecules and the walls of the container is the one that is really taken in consideration, because it's not collision between molecules, but it is the force upon an area, a real area. So completely the collision between gas molecules between each other is excluded entirely.
Okay.
So gas don't contain gas. Only a container can contain gas. Yeah.
Yes, if you have a surface of an object, like a globe, on the outside of the surface, if you unleash gas, which then has an acceleration, gravity, based on it, that gas will then be able to exert on itself pressure in all directions because it will have a pressure on the surface of that spheroid. That's the container.
A violation of the second law of thermodynamics.
It is not. It's in fact not.
It is a violation. You keep saying if there was. Sorry, you said if there was an acceleration, that would be decreasing the entropy of the system. Entropy increases. Fuck.
Okay, yeah. So the gravity would increase the system's entropy. Yes.
So prove it.
The law of nature applies to nature, the Earth, where the law takes place, because we talk about the Earth and nature. You're saying that where the Earth is, the nature that we describe and that we witness every day doesn't happen in the way that we describe and witness it happen every day. We observe entropy increase, gas filling space. You're saying no. If we imagine a force that's causing an acceleration downwards, then the gas will not fill the space. Unfortunately, the law states gas fills space. Your claim's in violation of that. I need an experiment where you cause gas pressure with gravity, please.
Yeah, I showed you again. I've told you a few times now that if you have a box without a lid and you have a gas in it, and there's a sufficient amount of acceleration on that gas will not escape from the top of the box. That's the point.
Again, open to atmospheric gas. Over time, the gas.
Even with the vacuum. Even with the vacuum.
Even with a vacuum. So
you just needed higher acceleration.
Sorry, I've got a container of sulfur hexafluoride, and outside is a vacuum. I open the container. What happens to the sulfur hexafluoride?
If there's a sufficient amount of acceleration on the sulfur, it will stay in the box.
Okay. The gas fills the space. This is what gas does when there's an available volume to fill. It fills it.
Unless an acceleration is being placed on it.
Right. You keep saying unless. This law of nature happens all of the time. The gas fills the space.
I know how entropy works.
Yeah.
The gas fills the space if there is no other forces exerted on it. If it is a gas in a vacuum without any kind of gravity, yes, it will evenly go ahead and increase the entropy and spread out evenly throughout that container.
That's what it does.
Yes, unless there is a force acted upon it.
No. That's what it does on the Earth, where your imaginary force that isn't a force and hasn't been a force for over 10 years. Einstein,
it doesn't do that, though. No, it doesn't just do that.
It just, excuse me, where all the gravity is, the thing that you're saying about gas doesn't happen. Gas fills space.
Gas fills space, except it doesn't escape into space, obviously. Like, how do you explain that?
Well, obviously, we're contained. We have gas pressure. Entropy would increase if we didn't have a container as an available volume to fill.
Well, no, the gravity keeps that gas along the surface of the spheroid.
But you can't experiment and show me.
I explained to you in the box.
No, you didn't.
Yes.
Remember, entropy increased at the time. You kept saying that the gas wouldn't leave, but it most definitely because entropy increased.
You could try it right now.
Trying to lie again.
No, you could try it right now.
No. Can you show us? Because I hope it's not a thought experiment and you are talking real now. So can you show us where did you read that shit?
No, I was in
did you
school.
see
They
that?
showed us.
No.
Yeah.
Can you show us? Go research in the internet. It doesn't take any
No, I saw
time.
it for myself.
No,
I saw it
so,
for myself
no,
in school.
I believe it's a dream. You saw it in your dream.
20 minutes.
That you release a box and gas will not go away from the box.
You've never had a
Yes.
dense gas in a box before?
Yes, and
Yeah,
over
it's
time
still
it
like-
leaves
still
because the container
It
is
will
open.
not. No,
Yeah, it
Isn't
will
it? Doesn't understand what an open system is.
it won't because
Even
the
if it
buoyancy
does,
will keep it there.
even
We
if it
have
leaves.
open
What
buckets
you're
of gas, do we?
But
simply
what you're
will not
saying
leave the
about
box.
gases with this gravity,
Now, what we
you're
have
saying it
open-
will never rain.
Just try it out. Just try it out if you don't
Okay,
believe me.
no worries. I'll have an open bucket of gas and see what happens when I try to sell it as an open bucket
When you
of gas.
try to what?
Try to sell it to other people as an open bucket of gas.
We'll make sure that you don't have any turbulence, which then pushes the gas out of the bucket when you move it.
Oh, fucking hell. So I can leave the bucket on the floor.
Yeah, you can't move the bucket because if you add more forces to it, then it'll move that gas out of the bucket.
Are you telling me that I can pour sulfur hexafluoride into a bucket and I can leave it there for a year and it'll still be there when I come back?
Yeah, as long as there's no other forces acting on it, absolutely.
What a retard. No, what about heat? What about heat?
What about heat?
Yeah, what about when the sulfur whatever it is, that gas, when that achieves room temperature, what happens to it?
Because it's denser than air, it'll still stay at the
No,
bottom.
it won't. It'll heat up to the surrounding medium. It will expand in all directions out. It will actually come out of the box. This has been shown objectively, so.
Okay, no, because the actual gas
Using
itself is denser. It's not about not about the gas.
No air above it.
Hold
What
on.
if there was a vacuum above it?
It depends. If there's enough acceleration put on it, then it will still stay in the bucket, even if there is a vacuum above it.
Good luck for showing me a boat made of aluminium foil float on the entries of caves. Welcome.
Yeah, hold on. You can absolutely do that. You can absolutely do that. Yes, you can do that. You could do that right now if you wanted to.
Yeah,
You should go to a coal mine. You should see how a coal mine works. They have to go ahead and get rid of entire chasms filled with dense gas.
Like that thought experiment that you were talking about. So you want to be able to breathe inside a cave. That's what you are saying, because the hexafluoride will just push away the oxygen that is less dense away out of
Because
the
of
cave.
gravity, yeah.
And, yeah, that's what you are saying. But still, people are not using breathing materials to enter a cave. They use just a mask to filter the dust that is produced by breaking the rocks there, but they don't use
whenever you go into a cave,
oxygen because they think that there is just hexafluoride and that heavy gas just pushes away all the oxygen and breathable gases. That's bullshit, brother.
So when you go into
Do you
a
want
cave,
me to show you people breathing normal air?
Yes, because they pump air down there specifically for this reason.
Do you want to see people just discovering a cave and entering the cave for the first time and didn't use any pump to extract?
Depends how deep the cave is.
To push or to add some oxygen to breathe.
Is the gas
Depends how deep the cave is.
Is the gas being produced down there?
In some cases, yes. It could be an off-gassing from different minerals.
Okay, awesome. So the gas is being produced.
And occasionally it can be from breakdown of natural materials.
Okay,
like
gas is going to be produced down there.
What's that, sorry?
So the gas is going to be produced in this cave that we're all talking about. I'm wondering why there's a lot of gas.
In some closed cases, yes, but not all cases.
Okay, show me the not all cases. You seem to be making a lot of...
Sure.
I would like you to go up and start providing citations for the shit that you say.
Yeah, citation, please.
Right on, gas. An awful lot of shit. Hold on. You seem to be saying an awful lot of shit and just denying obvious laws of nature and saying, no, the laws of nature don't work in the way that they're described.
But they do, except you just don't understand what acceleration is.
Okay, what causes the acceleration?
Gravity.
What's gravity?
A curve in space-time.
Okay, so you're not going to give me any science then? You're just going to give me a load of mathematics based on reification and office.
No, I didn't give you any mathematics.
So that's what it is. Curvature of space-time, a four-dimensional coordinate system, height, width, length, and time, and the distortion of those straight lines that are curved due to the displacement of mass. Yeah, it's definitely got
like a geodesic, yeah.
Got shitloads of math in it. Got tensor equations and loads of shit.
Yeah, I didn't explain any of that to you.
I know, but that's what you put down.
Well, I said, okay, that's like me saying, oh, but water flows from one place to another. Yeah, there's a lot of math and physics involved, but I'm still explaining to you that water flows downhill. You understand? I didn't say any math to you.
You told me that I don't understand things. I've asked you to define...
I didn't say that.
Yes, you did. That's why
I said that you're not listening regarding gravity and the box and the boundaries and specifically buoyancy.
You're not listening. You're not listening because time. Over time, one year, like, you think the gas is still going to be there, you idiot.
Yes.
You don't understand.
We're going to be there.
You're making shit up.
No, I'm not. You can go ahead and do this yourself.
Yes,
I take your bucket and I put a lid on it, right? And then I stick it in another chamber, a vacuum chamber, right? Yeah, and I expel as much air.
Cheetah, we can't hear you
I can't hear you.
at all.
Okay, sorry.
It's something about a bucket in a chamber, but it was super quiet.
We've asked him this question every time we open the bucket to the vacuum outside. He says, if there's an acceleration, the gas will not increase in entropy and fill the available space.
Better.
Yeah, because it's being specifically pushed against the surface by acceleration. Yes.
So what we need, if you're not going to provide citation, we need you to present a demonstration of gas, like whatever gas you like, without a container.
Is this any better?
And show that it maintains gas pressure without a container. So you could have a one-sided, you're saying a one-sided container. So have a one-sided container. We don't care what the side looks like. Put the gas on the one-sided container and then maintain gas pressure with just that one side. Present the demonstration.
One side?
Yeah.
Yeah,
the one that said it.
Yeah, the Earth.
Yeah, so provide the demonstration of this happening, that you can actually provide a demonstration.
Yeah, the Earth, where you're standing right now.
You're just repeating the claim. We need a demonstration. Provide demonstration. Gas pressure without a container.
Replicate.
Gas pressure without a container. Well,
Yeah,
the
like
surface
you
of the
said,
Earth is the container.
one said, no, it isn't. One side of a container. Present one-sided container that can maintain gas pressure. So put gas
If it's a globe,
onto a.
then
Well,
one
let me
side
finish
will do.
talking. Let me finish talking. So put gas onto a one-sided container and make sure that your gravity can provide gas pressure without any other sides. Present that.
Yeah, that's fine. So again,
Yeah, that's fine. It's not the demonstration. So we need the demonstration.
Okay, are you going to listen or just
Put the demonstration in the
interrupt me the
side
moment I
chat.
say anything?
Put it in the side chat.
Sure, I'll try to find a demonstration for you. Give me a moment.
Yeah.
Is there a
Make
container
sure it has no. Make sure it has no containers, and make sure you have identified the
It has
variable.
no containers now?
You would make one-sided container, and make sure you've identified the variable of gravity causing the pressure.
I've identified gravity causing
that's your
pressure.
statement. You're claiming.
Correct.
So yeah, we need the
If there's an
demonstration. now.
acceleration, so if
We
there's
need
an
the demonstration now. I don't care what you fucking call it. We need the demonstration of gravity causing gas pressure with a one-sided container with gases. Go ahead, provide the demonstration.
All right, that's going to be hard to do because the only thing around us that has gravity, enough gravity, is going to be the Earth to contain.
So what you're saying is that would make it unfalsifiable then, wouldn't it?
Well, no, I don't think so. I think.
Well, no. Okay, so how would you falsify that?
It just needs to explain.
Well, I mean, if all the gas were to up and leave the Earth, we'd know.
So you can't know it. So why did you deny that it's unfalsifiable? How would you falsify it? You can't.
Well, you'd use other experiments, but you know what? I'm going to go ahead. I'm going to try to see if we have an experiment to prove exactly what you said.
You don't have fucking one experiment. You don't have one single valid.
Well, I haven't looked yet. I'm going to look.
Gravity.
I'm going to look right now
Yeah,
because I'm
presented
very
gravity.
curious. You
Shut the fuck up. Listen, you don't have a single experiment from general relativity from 1915, November 25. General relativity, Albert Einstein. You do not have one single valid hypothesis or an experiment that is the test of the hypothesis. You don't have any of that for general relativity. But go ahead and try to provide us an experiment. That would have to be the case
for
if
general
it were
relativity?
science.
Hold on, we don't have any proofs of general relativity. Since
I said experiment. Didn't I say experiment?
Okay.
Valid hypothesis? Yeah.
Okay, so you're saying we had no experiments that proved general relativity since
scientific validation.
1915?
Yep, that would validate gravity.
Whatsoever.
Yep, as a cause and effect mechanism. Yep.
As a cause and effect mechanism for what?
It's your fucking claim. Now I have to define your claim? It's your claim.
No, I'm trying to understand what you're saying. You just said something. I want to understand what you're saying, so don't misrepresent it.
That would mean gravity would have to be shown in an experiment that it has a cause and effect of something. So you have the effect, which is your independent variable. That would be the one you're manipulating as the experimenter. And
The
two,
effect is
the dependent variable.
All right, I'm misunderstanding you because it seems pretty trivial to let go of something and see that something is moving without a force being exerted on it, and that would be gravity in this case.
Okay.
Like if you let go of a ball, it's going to hit the ground, right?
Yeah, now you're talking about bouncy balls. Great. We're talking about gas pressure.
Yeah, but gas pressure is done the exact same way. The same way that force is being exerted on the ball, the same force is being exerted on the gas.
Okay, can you put this into
Can you what?
Can you put this into a hypothesis, please?
No, what the fuck?
So science, natural science, it'll be a hypothesis. We're trying to abstract the science from you. You keep giving us explanations. Explanations are not science. We want the scientific evidence.
I'm not a scientist.
Okay, so you obviously believe this stuff. So do you know of the science that proves your claim?
I'm familiar with it. I'm not going to be able to do the math for you.
I don't want the math. I want the hypothesis. I want the science.
Okay, so I'll just make one. Then if objects are released from a height then they will fall towards the ground due to gravity. That's my hypothesis.
They fall to the ground due to gravity, therefore gravity?
No,
So
that's
you're
my
just going to
hypothesis.
make up something instead of refer to the people that
That's a
supposedly proved it
hypothesis,
to
though.
you? Yeah, but you
From the
need to refer
consequence?
to the people that proved it to you at some point. So why are you just going to make up something like a pretender claim?
Because I'm able to go outside and do
You're
it.
pretending to know what you don't.
Hold on.
Because I'm able to do it myself.
Within that hypothesis, what were the dependent and independent variables? I think I caught them, but remind me.
The independent and dependent variables.
Yeah, what was the phenomena and what caused it?
So gravity and a velocity on a object.
Okay, so for example, something fell like an apple from a tree. Yeah, that would be the phenomenon. Something happening, the thing that you said accelerated downwards. Awesome. You said that gravity will be the independent variable, your supposition of cause. Okay, I'll let this slide. Let's see if we can validate this hypothesis through an experiment where you or someone else making this hypothesis is going to have to very manipulate gravity, whatever the fuck that is, to see if it causes the acceleration down.
Okay.
Cool.
Go ahead.
Go outside and drop a ball.
Off you go.
No.
You are such an idiot, dude.
We get it all the time. That's the phenomena. That's the apple falling from the tree. Don't go out. Don't tell us to go outside and watch apples fall from trees. Remember, we've got to vary and manipulate the cause in an experiment. Science experiments, right? We do shit. Good. So we've observed the phenomena. Now we want to validate our hypothesis to see if the cause of it falling is gravity. To see if it is, not claim that it is.
Okay.
Yeah.
So then science, or a few people went ahead and looked at Newton's laws, and then we went into general and then special relativity. Like, it's all been figured out.
Let's stop right there. We need the independent variable. That would be the cause of the effect. When you say dropping something and it goes down, that's the dependent. That is the actual effect. So you're going to have to show that you manipulated something like the independent variable, gravity, and that you measured the change in the dependent variable. That would be the effect. So you manipulated gravity. That caused a change in the effect. That's what you're going to have to show.
Yeah, so that's just universal gravitation. That was figured out in like the 1600s.
Go ahead and manipulate it.
No.
Go ahead and manipulate it and tell us how you measured that manipulation.
The law of universal gravitation again was
Newton already did this.
Excuse me. The law of universal gravitation was superseded and toppled from the throne in 1950.
General relativity. I'm aware. Thank you.
Yeah, good. So we're going to get back round in the circle. The circle will be complete after you say, well, we went from Newton fucking physics to Einstein because of X, Y, Z. Like Flatsy asked you, can you pull out the hypothesis from the papers that he released in 1915?
I don't have them on me. You'll have to do that if you want that specific.
No, I'll have to wait for you to do it.
No problem.
I'm not going to do that for you.
It's okay. No problem. We've tried. We can't find it. It's not there. There's no hypothesis.
It is there. I can paraphrase if we want to continue having this conversation. Do you want me to paraphrase?
Go on then.
Massive objects warp the fabric of space-time, and other objects moving along the curves in this warped space-time we would perceive as gravity. That'd probably be the hypothesis, or my layman's terms version of it.
Okay, no problem. You understand in a scientific hypothesis, all things must be physical. You're not going to be using reification. No, hold on. You're not going to be using reification fallacies, for example, taking things that aren't physical, like love, hate, space, and time, and giving them physical entity through mathematics. It's not a scientific. It's not a scientific hypothesis.
Yeah, I don't see how this is relevant right now, because I didn't say that love is doing this.
The fuck, dude.
Okay, where did I invoke anything that's non-physical in those hypotheses?
Time and space. Mass.
Time and space are both physical.
Okay.
Oh, really?
Give me height, foot, length.
Give me a cup full. Can I have a cup full of time?
Oh my god.
Yeah, I'd like.
Well, no, you're moving through time just as much as you are in a 3D space-time. That's why it's called space-time.
No.
Yeah.
Height, width. Excuse me. The three coordinates, height, width, length, are not physical. They're conceptual. They're taken up, the volume of the height, width, length, by physical things like a brick.
Yeah, we're just describing reality. Yes.
Space that it occupies is not physical. Time is the passing from moment to moment. It's conceptual.
No, it's not. It's very much a physical phenomenon.
Okay, so give me some time, put it in a jar, set fire to it, and kick it down the road.
Well, that's not how it works. It's four-dimensional.
It's physical.
Oh, hold on. You got to listen, because you're talking about 3 dimensions. I'm talking about 4 dimensions. 3 dimensions of space, 1 dimension of time.
What do you think I'm talking about?
So you could have a dimension of time. It's a single dimension of time, and you're talking about somehow taking time into 3 spatial dimensions. That doesn't work that way.
No, that's what I've explained to you. The 4-dimensional pseudo-Riemannian coordinate system. Yeah, the 3 dimensions of height, width, length, and the 4th dimension of time
Mm-hmm.
put up. Now these
Yeah,
things
it's called
are
a model.
physical. Yeah, that's not physical. That's mathematics. You're going to give me a load of mathematics. It's not physical. Height, width, length isn't physical.
Okay.
Time is not physical. What's math?
Yeah, it's describing a phenomenon.
Right.
It's physical.
It's not physical. Give me
It's
some
describing
time.
a physical phenomenon.
Give me 3 cubic meters.
Well, time doesn't work in 3 spatial dimensions. Time works in
then it's
time
not
dimension.
physical.
It is physical.
It's
Okay,
not,
then-
it doesn't
then
work
give
in
us-
3 fucking dimensions of physicality. It's not physical. Now, is height,
Okay,
width,
define
length-
physical then. Maybe we just have a different definition.
God.
Because absolutely. Time, it's not absolute, but it's completely relative to an observer's frame of reference. So it absolutely is a physical dimension. It's interwoven with space, and it forms a 4-dimensional continuum called space-time. That's what I've been referring to, if you didn't know that.
Yeah, I know exactly what you're talking about.
Time is considered a fundamental aspect of the physical universe, just like the 3 spatial dimensions. It is not a conceptual tool. It is not mathematics. It is a fundamental aspect.
It is a conceptual tool.
It is not. You are incorrect.
It is mathematics. That's the point.
We describe it with mathematics. With mathematics. Well, no, it's not. It's a physical fundamental aspect. It's not an abstract.
It fucking is.
It's
Can I
not,
add,
though.
can I add energy to time? Does time
No, it doesn't
experience
work that way.
Does time experience entropy?
Time is, I would say, absolutely experiencing entropy. Time, I would say, is actually the driver of entropy.
Oh my God, he thinks time causes stuff. I'm out.
No, it drives entropy.
He's building a house out of 2 hours.
Is it
Building a house with hours?
Absolutely retarded, bro.
Great
Yeah,
argument.
it's not
I'll take that as your concession.
Karnemir, you have less than a 5th grade knowledge of science. Period.
And you can't argue against me because you're wrong.
Yeah, you're full shit. You don't have any experimentation.
The last vestige of the
based on
retard.
what the bullshit coming out of your blowhole.
It's
You have
okay.
no proof.
I always get the ad hominems when you guys lose. So
No, it's not. It's not that. We're not going to tolerate this invincible ignorance.
Oh, that is rich. That is fucking rich, Jedi.
then argue the point. Argue the point and stop saying about my education because clearly I've schooled you today.
We've argued the point, and you just don't get it, dude. I'm sorry. You're just talking to
Oh, you just don't get it. I just can't argue.
Yeah, time is
you did not say any proof at all, dude.
You just said that time's mathematics. Like you don't know the basics.
Time is not tangible.
Yes, it is. It's completely interwoven with space. It's a full dimension, a physical dimension.
How do you manipulate time?
You are currently moving through time right now.
What's tangible mean?
You are currently moving through time.
What's tangible mean?
Like in general?
Are you serious right now?
The word tangible. What do you
something
mean?
that you're able to perceive, I guess.
Do I need superpowers? Stop time.
Well, no, but you're moving through time right now. It's absolutely perceptible.
Glue sniffing Dude doesn't know what tangible means. He doesn't know what tangible means.
Yeah, no, the tangible is something that's perceptible. You're able to perceive it.
Try again.
He was asking what is physical.
That's real.
He was asking what is physical. He doesn't even know what is physical.
So you think tangible and perceptible are the same exact things? You think those are the same words, tangible and perceptible?
Well, no, we could agree on a definition.
Okay,
I see it as something being real or perceptible.
Man, you're such a weasel.
Definition.
What's your definition of tangible?
I'm going to give you one more try to make amends for yourself, to give a proper definition of a very
That's
easy
my
word.
definition. What's yours?
Do you just make up definitions?
We can use working definitions. That's what I understand tangible to mean.
Okay, why don't you do that?
I just did.
Why don't you do actual, so you're making one up?
That's how I understand tangible. Do you want me to cite you tangible?
Yeah.
We're dealing with somebody that thinks time is tangible.
Yeah, you're going through it right now.
Okay, so hand me a bucket full of time and paint it red.
Just again, time doesn't work in the 3-dimensional space. It's interwoven in space-time. It's completely on its own.
Oh,
It doesn't work in 3-dimensional space-time.
You got proof that rocks bend warpy time warp.
Yeah, because clocks are going to work differently depending how much energy a system has.
Time is not tangible. Time is a concept. Time is not physical.
Oh, it's physical. Oh, it's very much physical.
Oh, it's not.
How?
It is not tangible. It is a concept.
Let's have him explain to us.
Not a concept.
How is time physical?
Okay, no, it's not just a conceptual tool. It's a fundamental aspect, again, of the physical universe. I've already said this. It can specifically warp space-time, affecting gravity can warp space-time, affecting the flow of time. It's not just math. It's literally a physical thing.
No, it can't do that. It's not physical. It's not
Gravity
tangible.
cannot warp space-time?
No, it cannot because gravity doesn't exist. And time, because time is not tangible.
Yeah,
you understand?
Google tangible.
Oh, no.
Google tangible.
This glue sniffer hasn't defined gravity in the first place, so we can't use it anymore.
What do you mean? We had
You
this
haven't
conversation maybe
defined
an
it.
hour
You
ago.
haven't given us an experiment that proves gravity has a cause and effect on anything. I could just as
general
easily
relativity has done
I
that.
could just as easily say it's purple freaking unicorns with yellow
general
wings
relativity does
causing
that.
it.
Oh, you mean the
And
theory
it
of
would be the
general
same, it would have the
relativity?
same meaning.
Yeah, the theory of general relativity, yes.
No,
Also,
it hasn't proven shit.
Yeah, well,
gas
it's our
fills
best
all
guess so far.
volumes. Also, gas fills all available volumes. That's why it's a law.
Not if
They
there's a
never know.
force exerted on it.
So
Flat
a
Earth is our
container.
best guess, not gravity.
Hasn't proven that.
Yeah,
The
you
only
can do
thing
that
you
right
brought up
now.
were things like the only thing you brought up were things like caves.
Caves are a bucket with heavy gases.
Yeah, containers. Yeah,
That's not
holding
a
gas.
container.
But if
No, it
it's
has an
around,
open top.
if gas is around an available volume, will it fill it?
Without any other forces acting upon it, yes, it'll evenly distribute throughout the volume.
What is the law of entropy?
The law of entropy, that it always increases, I guess.
I guess.
What is it?
Why don't you brush up on the law of entropy and get back with us?
All right.
And tell us
The second law of thermodynamics states that as one goes forward in time, the net entropy of any isolated closed system will always increase. So, yeah, what I said paraphrased.
So is that a yes or a no?
Can you
I'm
look up
correct,
tangible
as
now?
usual. Go on.
Can you look up tangible now, Karnemir?
Yeah, sure, I can look up tangible. Give me a second, let me get on the... clear and definite. Real. Tangible.
That is not the first definition that came up.
That is one of the definitions, and the one that I used
What's
when I
the
said
first one?
tangible.
What's the first one?
Perceptible by touch.
Okay, there you go, Karnemir. Good job.
Yes, I use clear and definite or real when I use tangible.
You don't like that one, do you? Because you can't touch
Well, no,
time.
I don't use it that way. And in fact, well, yeah, you can. You actually can. You could experience it.
Describe physical, we do.
Well, you experience it. So, yeah.
No, you don't.
It's happening to you right now. It's touching you whether or not you like it.
No, but see, now you're just trolling. You're just turning into a fucking dickhead.
Well, no,
Not that you
that's
weren't
correct.
before.
You can get upset about it all you want.
You are definitely. But we're talking about.
He ended up with egg on his face. Now he's going to squirm.
Remember
What, because I use the definition and
science.
you don't?
We were trying to do physics, things we can touch.
Yeah, physics does work with things that we can touch. Yeah.
Now you can tell me
Also
how
works
it
with
works.
time, which
Now
we
you're going to
can't
tell me tomorrow.
potentially touch by your definition.
Okay. So tomorrow at 2:30, 2:30 is going to hug me, is it? I'm going to feel that hug.
Well, you're going to get there, whether or not you like it. You're moving through it right now. It's
Yeah, we're
pushing you
talking
through.
about things that we can physically interact with, like touch. Physics,
Yeah, you can
right?
physically interact with. You can physically interact with time. You can physically interact with that.
What does
Yeah, no,
gas
absolutely you
smell
can.
like?
For example, because of the mass, just the sheer mass of your mother, the closer you are to her, the slower time will move.
Yeah, your mum is so far. Yeah.
It's true.
What does 5 hours smell like? What color is
I don't think it has a scent, but his mother smells pretty bad.
Yeah, okay. So how can we experience it physically then? With what sense
You move
do
through
we
it.
use?
You move through it right now.
Which one of our senses do we use to perceive?
Ooh, that's a good question. I guess consciousness, like your ability to have memories in a future, past, and present. Your sense of existence and consciousness and belonging, I suppose. Like you have a memory, so you have the concept of the past and the future, right?
Those are all ideas. Those are all ideas.
Ideas? The past, present, and future are ideas.
Those are all ideas. Yeah.
They're not destinations.
No, they're not fucking. Is the past a destination?
Yes.
Oh, really?
You can never access it.
When did you go there?
I was there a second ago, and now I'm there a second ago.
So it didn't exist. It's just an idea in your mind. It's always the present. The now is the only thing that exists. So those other things are just ideas.
Okay, well, you say
so is
that.
now, as a matter of fact, even though it's something that we are.
Then explain why every single person has their own now. Then.
Well, can you
It doesn't make it physical. It's an idea.
No. That is making it physical. If someone who goes faster than you, or someone is closer to a larger mass than you, their idea of now will be different than yours.
Faster and slower are ideas.
You can't prove that. That's just
what
that
you mean. Yes, you can prove that. Of course, you can.
No, you can't. How?
Yes, you can. You can go ahead and send a clock up into a satellite. It's going faster and it's further away from gravity, and eventually the clocks aren't going to match up. That's how GPS works.
Sure. Okay.
You think
Sure. Okay, buddy. I don't know how to read. Okay.
So the clock is physical because you can push it. You can't push time.
He thinks his feet is in the
push
future.
time. No, but we can affect time. It's a physical thing that we're able to. Yeah.
How do you affect time, brother?
I already said this before. If you have a gravitational force, you can bend space-time and change the perception of time.
But
your perception. You just said it. Your perception of time. That's not actually
meaning that we're able to specifically affect it physically. We're physically affecting it.
How are
Which means you can go back and forth. Which means if you launch up off the Earth and you come back 50 years later, right? Your son is older than you, kind of thing.
Yeah. Sure.
That's what. That's what this guy's trying to push here. See, now there's nothing physical about what he's saying. This is a concept of thought that time slows down as you go up in altitude. It's stupid.
Yeah,
It's not
as you
physical.
go higher in altitude.
It's part of your globe. It's part of your globe religion.
My globe religion. This is just math.
No,
Nothing
it's
to
a
do with
religion.
globe.
That's your religion.
Hold on. One second. All of this would still work in a flat Earth.
Your scriptures
All
are
of this still
telling you
works in a
this.
flat Earth.
Your
Hold on. All of this works in a flat Earth.
scriptures are telling you these things.
Wait,
Your
hold on.
Your scriptures.
Let's say I'm a flat earther.
NASA is your priest, your church.
Okay. Let's say I'm a flat earther. All of this would still be true.
No, it wouldn't.
No.
Because
why wouldn't this work with the flat Earth model? It doesn't matter what the model that I'm using.
No flat Earth.
This would still work.
Flat Earth model right
You're not going to warp time in any capacity, are you? No. And just going high in altitude
This is independent of a flat Earth, though. This is just physics.
This is not physics because it's not physical. It's a concept, and you were right that it's mathematical because that's the only thing it is within a concept.
1 + 1
Okay,
is
so I went ahead and
space-time warp is not a part of math.
Okay, I sent you a link to it. It shows the LIGO lab and experiments that have actually proven this. It's absolutely a physical thing.
There's that word again.
Well, you brought it up. You wanted experiments.
Yeah, good. So what is the hypothesis, including the IV and the DV?
We already did this. I'm not doing it again.
Okay, good. You're bringing it up. You said experiment. So what is the valid hypothesis for the experiment? So we can go check it.
LIGO is not an
We
experiment.
already brought this all up. I'm not going to bring up the hypothesis. We're already an hour into this. We're not starting from the beginning.
You're just a sniveling little
Here come the ad homs when you're losing, as usual.
You're a glober. You're just as valid. Religious.
I'll take the ad homs as a concession. Thank you.
Yeah.
Time is based off of the rotation of the celestials. Doesn't have anything to do. Yeah, the celestials. Time. Yes, day and night.
Like what is a celestial to you? What does that mean?
The lights
in the sky? Like the stars and the planets and the meteors?
No,
the moon?
Like the stars and the moon and the sun. It's where we get time, the conception of it. Just because we go high in altitude doesn't mean those things do something different.
Hold on. What do you mean? No, time is completely independent of celestial bodies.
No. What time is it right now?
Depends where you are.
That's correct. Keep going.
You asked me a question. I answered your question.
Depending on where you are, meaning what?
Meaning where you are on the Earth. Meaning, hell, if you're not on the Earth, you're going to be experiencing time at a different rate than anybody else.
Well, you got that right. We're all
like I said. That other guy is so close to his giant fat mother that his time's going slower than the rest of us.
You got that right. We're all on the Earth. That's correct. We're all on the Earth. That's right.
Yeah, it's got nothing to do with going high in an altitude and sending a clock into the air and bringing it back down. The sun, moon, and stars are still doing the same thing, regardless of what you would like to fancy.
He had to put in one more "your mama's so fat" joke and then left. Hilarious.
Oh, he took off? He shrank into the horizon? I see.
He didn't answer up to anything he said. Not one
colorful dancing. Very colorful dancing. Tip of the hat to that. He had an answer for everything. That's what we're up against. Everything all colored in. Nothing proven. Most of it ridiculous. And going against physical laws.